Just 10 million Planck times after the Big Bang, a tiny volume of space suddenly starts to expand much more quickly than before. This inflation is so rapid that it turns chaos into order, spreading the constituents of our universe evenly throughout space and fixing their positions within it.
As the universe cooled down in those earliest moments, it increased in volume by a factor of 10 to the 90th in a millionth of a billionth of a billionth of a second.
It's like a grain of sand swelling to larger than the sun, faster than the speed of light.
Well, have we violated Einstein's laws? Nothing can go faster than the speed of light. And here's one of the real subtle points about the Big Bang. Space can expand so much that two objects appear to move apart faster than the speed of light, but they're not moving. It's the space in between them that's growing.
Guth's audacious idea, the inflationary universe, could push the limit of our understanding back to the very first moments of the first second. But how could we ever test it? How could we peer into the birth of creation? The answer lies in deep space. When we look up at the night sky, we look back in time. The light from the sun hits our eyes 8 minutes after leaving its surface. The light from a stellar explosion, a supernova, took 167,000 years to get here. It blew up when modern humans first roamed Earth. And as we look at more distant objects, the clock winds back still further.
When you're looking at distant galaxies, 10, 12, 13 billion light years away, you're seeing those galaxies as they were right after they formed. It's as if we have a time machine and we're seeing the universe when it was very young.
The Hubble Ultra Deep Field is filled with the first galaxies, the birth of stars. But this is as far back as the Hubble telescope can look. How can we go back further, closer to the birth of the universe? TV static holds a clue. 1% of the static on this screen comes from the light from the Big Bang. In 1964, astronomers Arno Penzias and Robert Wilson were listening to radio signals from space. But in every direction, they were picking up a background hum. Puzzled by the hum, they suspected they knew the culprit and swept the entire receiver free of pigeon droppings, to no avail.
If anything, the background got even greater. And according to legend, when they gave a talk at Princeton, one physicist raised his hand and says, either you are listening to the effects of bird dropping or the creation of the universe.
What Penzias and Wilson had stumbled upon was the afterglow of the fireball created by the Big Bang.
As the universe expanded, it cooled. After a few 100,000 years, it was just protons and electrons flying around. But at some point, the universe cooled enough that when an electron and proton got together all over the universe, essentially all at once, the universe became transparent.
Think of a gigantic fog that suddenly lifts. Before the fog lifts, you can only see a few feet in front of you. Then suddenly, everything becomes clear. That's what happened 380,000 years after the Big Bang.
Ever since that moment, 380,000 years after the Big Bang, this light has traveled uninterrupted through space. Scientists call it the cosmic microwave background.
If you were to write down a handful of the greatest scientific discoveries of all time, one of them might be the discovery of DNA. Another one might be the discovery of the cosmic microwave background. That's how big this discovery was.
The cosmic microwave background first lit up the universe 380,000 years after the Big Bang. But it bears the imprint of a time much earlier than that, a time when inflation was transforming the cosmos. If the secrets to inflation are anywhere, they're hidden here. Scientists needed to take a closer look. May 2009, the European Space Agency launches the Planck satellite. It orbits the Sun, scanning the temperature of the entire visible universe. It's so sensitive, it can measure the temperature of the cosmic microwave background to within 1/1,000,000th of a degree.
The blue spots in the map are cold spots. They're going to evolve to become large empty voids. The red spots in the map, those are hot spots. They're going to form clusters of galaxies. This map is a blueprint for how our universe is going to form and evolve. When we look at this map, we're also looking back in time and seeing the echoes of creation.
The tiny variations measured by Planck go on to form the galaxies that fill the universe, and inflation explains them perfectly. But scientists need a smoking gun, something out of science fiction: gravitational waves.
One of the tests is that we might be able to see the gravity waves that were produced at the very end of inflation.
Gravitational waves stretch and contract space-time itself. They travel through the universe like ripples in a pond. Scientists believe that the violence of inflation sent these waves reverberating throughout the cosmos. If we could see them, it would be case closed. Scientists would know that inflation was real. March 2014, 30 years since Alan Guth came up with inflation. A telescope at the South Pole shakes the world.
Today, scientists announced they have discovered what was going on in the earliest moments of our universe, right after the Big Bang.
This is the most exciting scientific result of my career. Inflation was an incredibly violent process. Different parts of the universe all expanding at somewhat different rates, but all faster than the speed of light. And this difference in expansion rate produced gravitational waves. And these gravitational waves produced a signature on the microwave sky that we've now seen. It's something I am so happy has happened in my lifetime.
The data is an almost perfect fit for inflation.
What we're finding is that the very simplest models of inflation are agreeing beautifully with what observations are being made. And that's incredibly gratifying and provides, I think, very strong evidence that inflation really happened.
Inflation explains why galaxies are spread so smoothly across the cosmos. In the tiniest fraction of a second, it transforms a minute and uniform bit of space into the entire visible universe. And the implications are stunning. Maybe it wasn't just the visible universe that grew under inflation. Some scientists now believe that other regions of space, too distant for their light to ever reach us, underwent inflation too and are still inflating now.
One of the profound things about inflation is once it starts, it's hard to stop it.
Inflation never stops everywhere. It stops in places. And every place where it stops, one produces a universe. Inflation seems to go on producing other pocket universes literally forever.
Indeed, inflation makes our Big Bang and then goes on and makes lots of other Big Bangs and creates this big collection of universes, the multiverse.
Our universe may just be one of an infinite collection of universes in a multiverse much, much larger than we ever imagined. And some scientists argue Not only are there multiple universes out there, they think every possible universe must exist. People identical to us would live out every possible parallel life in every possible parallel world. It's a mind-blowing outcome.
Now that we have such strong evidence for inflation, it's time to take ideas like the multiverse really seriously.